Good evening, children. Today we will see one interesting topic, gravitation. This is grade 9 portion, both CBSE, state syllabus, ICSE, all syllabus is same, gravitation. See children, gravitation. In this lesson, we will see first of all introduction part. What are the important points in gravitation? Who introduced the concept gravitation? What is the definition of gravitation? What is the value of gravity on the earth, moon, sun? What is the acceleration of the moon towards the sun? All these things we are going to cover in gravitation. See here, first of all, the concept of gravitation was introduced by Sir Isaac Newton in 17th century. In 17th century, Sir Isaac Newton introduced the concept gravitation. You know one small story, when he was studying in Cambridge University, 1 year it was locked down due to plague. At that time, that Apple story you know very well. Based on the Apple story, he introduced the concept gravitation. Based on the gravitation, he explained how moon is revolving around the earth, how earth is revolving around the sun, all planets are revolving around the sun, how we are walking on the ground, how we stick on to the ground, all these things he explained in a detailed manner. Now, see children, Newton proposed gravitation concept in 17th century. Now, what is meant by gravitation? Gravitation means, let us consider this is the earth. A body, let us consider a body is on the earth or above the earth. Every body on the surface of the earth or above the earth is attracted towards the center of the earth. This concept is called gravitation. Gravitation means the body on the surface or above the surface is attracted towards the center. This is called gravitation. See, this gravitation varies from place to place. This gravitation is denoted by small g, also called acceleration due to gravity. Gravitation denoted by acceleration due to gravity is denoted by g. This acceleration due to gravity on the earth is 9.8 meter per second square. Acceleration due to gravity on the moon is 1.67 meter per second square. This is the gravity on the earth, this is gravity on the moon. Now, gravity on the sun is 27.4 meter per second square. That means gravity on the earth is 9.8, on the sun is 27.4. That means approximately 3 times more. You can write like this also, gravity on the earth is equal to gravity on the earth by 6 times on the moon. That is equal to gravity on the earth into multiplied by 3 times on the sun. This is the relation between acceleration due to gravity between earth, moon and sun. Now, this acceleration due to gravity is independent of mass. Gravity does not depend on the mass of the object. Let us consider the gravity on me is 9.8, on you also 9.8, on this whole building also 9.8. That means acceleration due to gravity doesn't depend on the mass of the object. It depends only on the mass of the planet. Comparatively, Earth mass, our mass is negligible. Even though it is a tall tower, multi-stored 200 floor building, Eiffel Tower, or if you take Burj Khalifa building, also negligible. The mass of the Burj Khalifa building is also negligible compared with the mass of the Earth. That is why the Earth mass is 6 into 10 power 24 kilogram. Comparatively, this mass 6 beside 24 zeros here. Come to this building mass is negligible with compared with the planet. That is why gravity does not depends on the mass of the object. It depends only on the mass of the planet. Clear children? Once again, the concept of gravitation was introduced by Sir Isaac Newton in 17th century. Gravitation means the body on the earth or above the earth is attracted towards the center of the earth, not by the surface. Every body is attracted towards the center of the planet. This is called acceleration due to gravity, denoted by small g. Acceleration due to gravity on the earth is 9.8, on the moon 1.67, on the sun is 27.4. Now the relation is earth gravity is equal to by 6 on the moon and 3 into g on the sun. Clear children? Note down up to here. Next see children, this is the earth. Mass of the earth is, already I told you, 6 into 10 power 24 kilogram. From the center of the earth to the circumference, this is called radius of the earth. Radius of the earth also, remember children, 6400 kilometer or 6.4 into 10 power of 6 meter. Remember this also, 6.4 into 10 power 6 meter. This is the radius of the earth, this is the mass of the earth. Now see children, this is the moon. Moon is the only natural satellite of the earth. Natural satellite of the earth is moon. Now moon is nearly 3,85,000 kilometer from the surface of, from the center of the earth, 3,85,000 kilometer. Always distance must be measured from center to center, remember. Now it is revolving like this. Now why it is revolving? Because it is producing some acceleration towards the center, that you know very well. Why? Because this moon is continuously changing its direction, so that some velocity exists in tangential, so that acceleration produced towards the center. This is called centripetal acceleration. Now what is the acceleration of the moon towards the earth? Earth acceleration towards the moon is 0.0027 meter per second square. All these derivations you will learn in higher grade, but I will tell you the procedure how to tell you in next video. If possible, in this video only we will see acceleration of the moon towards the earth is 0.0027 meter per second square. Very small acceleration. This is what very small acceleration. With this acceleration, moon is revolving around the earth. Note down this point is also children. Next of all, we will see what is universal gravitational law. Very important concept children. Newton's universal gravitational law. Newton's universal gravitational law. See children, very important concept. Imagine any two bodies. These are the two bodies in this universe. Imagine any two bodies, but these two bodies must be point mass. Of course, these two are, let us consider, two planets. These two planets also we will consider as a point mass. Sir, planet is very big now. Simple logic. These two are distance, compare with the distance is very far. That is why we two considered as a point masses. These are the centers. Center to center, let the distance is r meter. The mass of the first planet is m. Mass of the second planet is small m. See children, every body in the universe attracts another body. This body is attracting this body towards this side. With the same force, this body is also attracting this body. Both are attracting with the same forces. Otherwise, what will happen? This body will attract more. By default, this will come onto this block. Correct or not? Mass of the earth is more. Mass of the moon is less. If earth attraction is more, by default, moon should fall on the ground. But that is not happening. See, if these two bodies are of course two different masses, but the force of attraction is same. This is what Newton gravitational law says. This body is the first body is attracting second body. This is the second body attracting first body. These two always equivalent of opposite. Now see children, this gravitational force is directly proportional to product of their masses. If you multiply, if mass is more, force of attraction is also more, and inversely proportional to square of their distance between them. This is called Newton's universal gravitational law. Simple children, every body in the universe attracts another body with a force which is directly proportional to product of their masses and inversely proportional to square of their distance between them. If you remove proportionality, one constant is required, that is capital G, remaining as it is. Note down, F equal to G mm by r square. This is what Newton universal gravitational law. Sir, what is F? F is the force of attraction between two bodies. Of course, F maybe you can write it as F12 or F21. What is capital G? Capital G is called universal gravitational constant. Universal gravitational constant. Sir, what is its value? Very important. 6.67 into 10 power minus 11 Newton meter square by kg square. This is the value of capital G, children. 6.67 into 10 power minus 11 Newton meter square by kg square. This value is constant everywhere in the universe. In numericals, by default, you have to remember this. What is capital M? Mass of the first planet. Mass, let us consider this is the Earth. Earth mass is 6 into 10 power 24 kilogram. What is small m? M is mass of the second object. R is the distance between centers. Distance between center to center. One more important thing, what is the direction of this force? Force always lies along the centers. From this center to this center, this center to this center. Along the line joining between two centers only force acts. Example, let us consider here is one object, one building of 5 floors. Here another building of 10 floors. Now this is the center of first building, this is the center of the second building. Now gravitational force acts along the line joining between these 2 points. Don't take like this is wrong. Always force exists between their centers. This is the meaning of universal gravitational law. Once again, children, what universal gravitational law says? Every body in the universe attracts another body with a force which is directly proportional to product of their masses and inversely proportional to square of their distance between them. What is the meaning of this sentence, sir? We will see one small example. Let us consider. See, children, mass of the first block is small m. Mass of the first block is, let us consider small m. Second mass is, let us consider 2m. The distance between center to center is, let us consider center to center, it is 4 meter. Now what is the gravitational force between them? Now say same formula, F is equal to, can I write directly Gmm by r square, this is the formula. Now what is G value? G value is 6.67 into 10 power minus 11 Newton meter square by kg square. Capital M is small m is 2m, by r is 4 4s are 16. Correct, children? 2 1s, 2 8s, 8 1s, 8 0s, 8 7s, 8 7s are 63, 3 remainder 37, 8 4s are 32. Simple, 0.74 into 10 power minus 11 m into m square. This is the force acting Newton, m square Newton. This is the force acting on between two bodies. Let us consider this is 1 kg, this is 2 kg. This is 1 kilogram, this is 2 kilogram. At the time, what you can write? Simply you can write it as, change it here. This is 1, this is 2, 1 into 2. At that time, what will happen? 0.74. Directly you can write it as 0.74 into 10 power minus 11 Newton. This is the force acting between 1 kg and 2 kg blocks. This is the way of doing. Clear, children? Now see, one more example I will tell you. Now see, now initially the masses of the blocks are F is equal to Gmm by r square. This is the formula. Initial mass is capital M, second body mass is small m, distance between two centers is r. Now what I am doing? Now first body mass is reduced by half. I made initially m, now I made it a 2 m by 2. Second body mass I made m becomes 2m. This I made double. Distance between them became half. Now center to center the distance became r by 2. What is the new force acting? Initially mass is capital M. Initially mass is small m. Second body mass is small m. Distance between them is r. Now I made m is m by 2. This one I made half. This one I made double. And distance reduced to half. Now let it, this is F1. F2 is equal to what will happen? G do not change. Universal gravitational constant always constant only. Capital M is nothing but m by 2. Small m is nothing but 2m by r is nothing but r square by 4. Square not here. So that r square by 4. All constant values keep it aside. 2 cancel. This 4 goes into numerator. 4 keep it aside. Gmm by r square. What is gmm by r square? F1. So this is nothing but 4 times of F1. That this is the answer. That means if first mass is half, second mass is double, distance becomes half, so that the force increased by 4 times. Without doing also you can say here directly proportional to masses. Multiply these two. 2 cancel. Denominator square. R square by 4 comes into numerator. 4 times increases. 4 times the force increases. This is what gravitational law problems. Now, sir, how we got all the time you are saying Newton meter square by kg square? How we got this value? Simple. Same formula dear. F is equal to gmm by r square. This is the formula. I want G value. G is equal to what will happen? By 1 cross multiply. I want only G value. Send this fellow this side. Fr square by m into m comes to this denominator. Now, what is the SI unit of G? SI unit of capital G is equal to force SI unit Newton, distance meter square by mass kilogram into kilogram square. This is the SI unit of capital G. Also, you can write it as Newton meter square kg power minus 2. This is what SI unit of capital G. Once again, Newton universal gravitation are very important here. Every body in the universe attracts another body with some force. This body is I am attracting the building. The building is attracting me. So, this force is almost negligible. Why? Because gravitational force is a weak force. Now, we will see what are the properties of gravitational force. See children, properties of gravitational force. See children, this is the first body, this is the second body. These two bodies may be living bodies or non-living bodies, and doesn't matter. But every body is attracting another body with some force. This force is already, I told you, directly proportional to masses, product of masses, and inversely proportional to square of their distance between them. See here children, this force is a gravitational force property. First property is it is always attractive. Attractive force. Gravitational force is the attractive force, never repels. Electrostatic force, like charges repel, unlike charges attract. Magnets, like poles repel, unlike poles attract. North repel, north south attracts. But gravitational force is not like that. It is always attractive. Number 2, gravitational force is a weak force here, very weak force. If it is a strong force, we will attract the building, means we will go towards the building, we hit to the building, we will die. That is not happening. That is why gravitational force is a weak force. Why? Because already I told you capital G value 6.67 into 10 power minus 11 Newton meter square by kg square. What does it mean? After 0.11 zeros you have to put 1, 2, 3, 4 like this. Imagine how small it is. But acceleration due to gravity is 9.8. Acceleration due to gravity, earth gravity is very high, but coming to gravitational force is very less. Gravitational force exists between any two bodies. Acceleration due to gravity is the acceleration towards the center of the earth. Earth center is attracting with very high force, the acceleration. That is why we are stuck onto the ground. We are walking, running, we are surviving only because of the gravity. If there is no gravity, imagine this earth also would escape from the earth. At that time, no living organism is present on the earth. Its gravity is very high. Gravitational force is very less. Number 3, first one, gravitational force is the attractive force. Gravitational force is a very weak force. Number 3, gravitational force is a central force. Central force. Well, sir, what does it mean? Central force means it is always acts between center to center, dear. Center of body to center of body. This is what gravitational force is, a central force. Now, number 4, one more interesting thing children. Gravitational force does not depend on any medium. If you place kerosene or petrol or anything medium, it is independent of medium. In between me and that building, 100 cars are present. Even though 1000 cars are present, in between 100 buildings are present, it doesn't matter. The attraction between building and me do not affect. That means it does not depends on the medium. Gravitational force is independent of medium, dear. Once again, gravitational force is the attractive force, gravitational force is a weak force, gravitational force is a central force, gravitational force is independent of medium. Last one, it is valid only for point masses. It is only for point masses. Sir, what does it mean? It is not a point mass now. If of course if they are very far, we can consider as point masses. But where these point masses are exactly useful means it comes in plus 11 here. Example, this is what one rod. One particle is here. What is the gravitational force between these two means you cannot consider from this center to this center. Why? Because this point is very close to this point. So here attraction will be more, here attraction will be less. At that time, we will split into small parts. Then after we use the differentiation concept, dm by dx concept we will see. That we will see later. Till here you have to remember, children. One more example, last example we will see. Gravitational force. Try to understand, take number of numericals and try to solve it. Now see, children, this is what capital M value, this is what small m value, this is R value, this is what new force. New force we need to calculate. 2-3 values I will give you. You have to practice. Capital M value, let us consider 2 kg. Small m value 1 kilogram. Distance between them 2 meter. Find the new force. What is the new force? Simple formula, F is equal to Gm by R square. Initially let it be equation 1. Now F2 is equal to G. Capital M is nothing but 2 kg. This is what 2m. Small m is 1 kg. So small m. By distance R becomes 2r. So can I write 4r square, 2r square, 4r square. Now divide 2 and 1. F2 by F1 is equal to this total by this total. I will do once. 2 by 4, keep it aside. Gm by r square whole by Gm by r square. So this total value would be cancelled. 2 1s, 2 2s. So F2 is equal to F1 by 2. That means initial force by 2 times less, half. Like that, remaining 2 you have to do and write in the comment section. Now second one, I will 5 kg, it is 5 kg, it is 3 kg. Now distance between them is 6 meter. Find the answer. This is 10 kilogram. This is what, let it be 7 kilogram. The distance between them is 8 meter. These two, find out the answers and write in comment section. Practice well. All the best. God bless you.